What if I told you that within just an hour or two, you could build an AI-powered search system that's smarter than Google, just using Azure? Are you interested? Hello, my name is Maxim and I'm a practicing IT consultant. On my YouTube channel, I dive into real-life projects and share the lessons I've learned along the way. Trust me, being an IT consultant is anything but boring. It's packed with crazy challenges and non-stop action. I'm pretty sure you'll find something here that you're looking for. Today's topic is artificial intelligence. Specifically, we'll delve into Retrieval-Augmented generation. You may have heard RAG. Let's explore why RAG is valuable and how we can effectively integrate this technology into our solutions. While there's plenty of information available on AI RAG technology, many resources focus on theoretical principles. On my channel, I dive into practical applications, showing you how to implement technologies in your own projects, and it will be the same today about AI RAG. What might make my demo even more valuable to a wider audience is that it's built almost entirely with no-code technology. It's powered by logic apps. We are diving into the exciting world of AI RAG technology and how you can leverage Microsoft Azure powerful services to implement it. If you are a developer looking to enhance your skills in AI and cloud integration, you are in the right place. In this video, we will explore how to build an AI-powered document ingestion and retrieval system using Microsoft Azure Logic Apps, Azure Function, and Azure AI Service. Let's get started. This video will cover understanding AI RAG technology, what RAG is and how it enhances AI systems by combining retrieval-based methods with generative AI models. Setting up a document ingestion workflow using Azure Logic App, Azure Function, and Azure AI Search service to tokenize and store documents for efficient search and retrieval. Building a chat-enabled search workflow, creating a chat-based interface to query stored documents and retrieve relevant information using Azure Logic App and Azure AI Search. Demonstration of AI-powered document retrieval. A live demo showcasing how users can upload documents and how the RAG technology retrieves the most relevant information in real time during a chat interaction. Before we dive into the workflows, let's first understand the core concepts of RAG and how it works with vector databases like Azure AI Search. What is RAG technology? RAG, or Retrieval-Augmented generation, combines two essential AI technologies. Retrieval. This is the process where the AI system searches a database or set of documents to find relevant information. Generation. The AI uses generative model to craft responses based on the information it retrieves. This blend makes AI responses much more accurate and contextually relevant. For example, instead of guessing based on training data alone, the AI can retrieve specific pieces of information from a preloaded set of documents, ensuring precise answers and letting you search information in your own documents. RAG combines the strengths of retrieval-based methods with generative models to create a more robust AI system. Essentially, it enables the AI to pull in relevant information from a document or dataset, enhancing its responses. This is particularly useful in applications like chatbots or customer service automation, where accurate information retrieval is crucial. Now let's talk about storing documents in a vector database. When it comes to searching large amounts of unstructured data, traditional databases may struggle to deliver accurate results. This is where vector databases come into play. An embedding model is used to convert this unstructured data into a more useful machine-readable form. The embedding model processes the content and converts it into a set of embeddings. Each embedding represents the semantic meaning of document parts. A vector database stores the content in a mathematical form known as vectors. These vectors represent data points in a multidimensional space, making it easier to perform tasks like similarity search. In this demo, I'll be using Azure AI Search, a cloud-based vector database designed to store and search unstructured content. Azure AI Search breaks down your documents into embeddings, which are vector representations, and indexes them for faster retrieval. Let's unpack these key concepts. What are vectors? A vector is simply an array of numbers that represents a point in some multidimensional space. In the context of AI and machine learning, vectors are commonly used for representing data points, for example, features of an object, text, or image, and for calculating similarity or distance between the two data points. What are embeddings? An embedding is a specific type of vector used to represent data, typically in a more meaningful and compressed way. Embeddings are generated by machine learning models and capture the semantic meaning of features of the data, text, images, and sound. In natural language processing, for instance, embeddings are vectors that represent the meaning or context of words, sentences, or documents. These embeddings are trained to reflect relationships like synonymy or semantic similarity. Azure AI Search uses these embeddings to quickly find documents that are semantically similar to the search query. When a query is made, such as, for example, asking about best practices for cloud security, the system searches for documents embeddings that are closest to the query in the vector space. In RAG systems, the retrieval phase is critically important. By using vector-based document storage, we can increase accuracy. Similar documents or pieces of content are grouped closely together, which means the system can return more contextually relevant results. Handle large volumes of data. Even with thousands of documents, vector databases can efficiently search and rank the most relevant ones. Facilitate AI-driven search. Unlike traditional keyword search, vector databases understand the meaning of the content, making them ideal for applications like AI chatbots or semantic search engines. My demo leverages a comprehensive collection of examples from Microsoft engineers available on GitHub in the Azure Logic Apps repository. You will find a link down below in the description to this video. The solution demonstrates two workflows. Document ingestion. I will upload documents that get processed, tokenized, and stored in the Azure AI Search database as vectors. Document search. When a user queries the system, the Azure AI Search database will retrieve the most relevant document embeddings, allowing the AI to generate contextually accurate responses. You might be wondering why we need to develop such a sophisticated and potentially more costly method for document search. The answer is, with this method, you can harness the power of generative AI to search your own and your company documents using natural language queries, also known as prompts. In this section, I'll walk through the architecture of the AI-powered document search system. This architecture is built using Microsoft Azure services to create a fully functional Retrieval-Augmented generation system. Let's break it down step by step. The example architecture consists of four main components. First, Azure Logic App. The solution uses standard Logic App with two workflows. One for document ingestion, and the other for interacting with the stored documents through a chat interface. Number two, Azure AI Search. The service is the backbone of the system. It acts as a vector database where we store document embeddings. When a document is ingested, it's converted into vectors and indexed in the Azure AI Search database for efficient retrieval during queries. Next is Azure Function. Azure Function is used for document tokenization. This function converts document contents into tokens. and uses Python code for this. This is the only piece of code in this solution. And the last one, Azure OpenAI service. The OpenAI service is used to deploy AI models that handle both embedding generation and chat completions. The RAG system retrieves relevant content from Azure AI Search and generates responses based on user queries through this service. Here's a closer look at how the ingestion process works. Let's jump into the Azure portal and find the logic app hosting the ingestion workflow. I use the standard logic app and the two workflows in it. So we go to the ingestion data workflow first. Let's open the designer. And here you see that as an entry point, it uses an HTTP trigger. The ingestion process starts with a post request to the logic app's HTTP trigger. We pass the document URL and name as an input. So I have a JSON schema set on the HTTP trigger, which means that I have to send a document, a JSON document with document name and file URL attributes in it. So having the URL to the document, I use an HTTP request to fetch the document from the source. It can be anything. I will use the blob storage as a source for my documents. Next, the workflow calls an Azure function. This function takes the document, tokenizes it, and prepares it for storage in the Azure AI Search database. These tokens are sent to the Azure OpenAI Get Multiple Embeddings connector. For the tokens, the OpenAI service generates embeddings. These embeddings are numerical representations of the document's semantic meaning. The next step is Azure AI Search Index Multiple Documents connector. The generated embeddings are then stored in Azure AI Search database. This vector database indexes the embeddings, making it easy to retrieve relevant documents based on search queries. As you see, I have specified Azure AI Search index name here. It is a parameter, and the value is chat index. So let's go to the Azure AI Search. And here in the AI Search service, under the search management, we'll find indexes. So this index is used by the logic app workflow. The index file I've taken from the same Microsoft GitHub code repo where I've taken the sample files. And the file looks like this. When you create a new index in the AI search service, you select Add Index JSON, and then you remove the proposed data structure. You have to copy and paste the JSON which contains the index description. So here you can find fields which are used for indexing the documents uploaded to the service. Upon saving, you will get a new index with a name given in the name to the index file. The second part of the architecture is a chat interface. So let's get back to our logic app and find a chat workflow. Users can interact with the system by sending queries through the chat workflow. This workflow is triggered by a JSON payload sent over HTTP that contains a natural language prompt. So here you can see the HTTP trigger as well. With use of Azure AI Search connector, this one, the workflow interacts with Azure AI Search database to find documents whose embeddings are most similar to the user query. So here you can see there are a few steps preparing data for search. We have a statement specifying our search intentions and specifying the context for the search, giving it sample of responses, so we can set up the ChatGPT to respond in a way which we prefer. A few more instructs on how to give a response, and then there is a step which generates the JSON structure which will be sent to the search query. I want to remind you how these steps of the Logic App workflow look at the diagram which I showed you earlier. In this workflow, we will send the request, the query, to the workflow first. It will then be sent to the chat model to create a query. Then it will be sent to the embeddings model to get the embeddings for this query. Then these embeddings will be sent to the AI search service, to the storage of our documents. So as a result, we'll get the vectors for the documents found in the database. So actually, at this step, we get the search result. And then we take these vectors and send them to the chat model again. And here we send both the initial query plus vectors gotten from the AI search service. And the chat model will generate the response to the client. And this response will be prepared with use of ChatGPT and the LLM provided by the OpenAI service. So let's get back to the workflow. These are our steps: get search query, send to the chat model, get a single embedding, sent to the embedding model. Then it executes the vector search, and here the request is sent to the AI search service. At this step, we get the embeddings found relevant to our documents. And finally, the create prompt, which prepares the prompt, which is then sent to the chat model. So this step returns us the result of the search prepared by the chat model. So what we want to get here is that the response is prepared by the model, which uses both retrieved data from the AI search database and its own understanding for generation of detailed answer to the query. Once both Logic Apps workflows, Ingestion and Chat Workflows, and the Azure function are deployed, we can use any HTTP client to upload document and interact with the system via chat. I'm going to use Thunder Client, a lightweight HTTP client extension for Visual Studio Code. For my demo, I've uploaded my documents to the storage account blob container. These documents are easily accessible by URL. With this architecture, we can build a robust and scalable AI-powered search system using Microsoft Azure Cloud Services. Now let's jump to the most interesting part of my demonstration, practical action. I want to give a couple of comments first. I used Azure OpenAI service to deploy AI models. So if you go to the Azure OpenAI service and then to model deployments, and then you click on Manage Deployments, you're transferred to OpenAI Studio, and here you are able to deploy your models. So in my demo, I used two models, chat model and the embedding model. So for chat model, I have chosen GPT-4 Omni. And for the embedding model, I used the text embedding ADA 002. So these are available models in the Azure. You can use them, and there are other models as well. So for instance, I will just quickly show you if you want to deploy this model. So you get a list of pre-trained models available for your use in your solutions. Okay, so I have two models. Then I also use AI search service. This is the instance which I have created. And here I need to create the index, which will be used for uploaded documents. So I create a new index from JSON. And I copy and paste the content provided in the GitHub code repo. You'll find the link down below in the comments. So the new index is created. As I said, the uploaded documents will be indexed by this index. Now I'm going to show you how easy it is to use such a solution from any HTTP client. So we go to the workflow, and here I will choose first the chat workflow. In the designer, we select the trigger, and in the settings, in the parameters, you will find the HTTP URL to the trigger. So if you copy this trigger URL, you'll be able to call this workflow by this URL. So with this URL, I go to the Visual Studio, where I have the Thunder Client extension installed. And this Thunder Client works as a simple, lightweight HTTP client, analogous to the Postman. So I paste the URL to the Logic App Workflow trigger here. I'll choose the operation type post. In the body, I will put the JSON structure with a single attribute named prompt. In the prompt, I'm going to send a question to this workflow and eventually to the ChatGPT. For demonstration purpose, I'm going to work with a document named Global EV Outlook 2024. Global Electric Vehicles Outlook. This is a report provided by Electric Vehicles Initiative, issued in the year 2024, as we may suggest, which means that OpenAI ChatGPT service is unable to provide us information from this document. The ChatGPT and OpenAI service was trained on data until September 2021. So we can assume that requests to OpenAI for data created after this point in time will cause, it will not be an error, but the OpenAI will answer that it doesn't know. It was trained on data which do not include the latest ones created after 2021. So let's check it. And for checking this, I'm going to use a question which will ask for information from this document affecting the year 2023. So let's give it a try. And as assumed, the service, our workflow built on the Azure service responded, I don't know. I have another example. Let's check it once again. What are oil displacement prognosis according to the Global EV Outlook? I don't know. And I'll use the third one. How advanced became EV charging infrastructure in EU in 2023? I don't know. Sounds good for me. And this is expected. So the next step in the demonstration, I'm going to use ingest data workflow, and it will be used just the same way as the previous one. So I will take the URL of the HTTP trigger of this workflow, and I switch over to the Visual Studio Code. I have pre-created the ingestion workflow here. So here you see I, of course, pasted the URL to the HTTP trigger. I use the post as a verb, as an action. And the JSON document, JSON structure, which will be sent to this workflow, includes two attributes. One, document name with the name of my document, which will be uploaded to this search AI search database, and the URL to the document. For this demonstration, the document resides on the blob storage in the Azure. So I have created SAS key URL, which allows to download the document from the storage. So I send this request to the Logic App workflow. It is accepted and the workflow responds right away. But if we switch to the workflow itself, you see that it's still running. The document is being processed. And now it's finished. So if we step back and refresh it, we see that the document uploading is finished. At this step, the document is tokenized and uploaded to the vector database. So now the document is available for searches. What I'm going to do now, I switch back to my HTTP client and again to the chat workflow. And now I'm going to resend the same last request. How it once became EV charging infrastructure in the EU in 2023. Send it again. And now you see that the response is completely different. The service returned us information from the document which I have uploaded. This was a PDF document of about 170 pages, a pretty big report about how the electric vehicles are taking the marketplace, how the infrastructure is being developed with the state on the year 2023. So to this question, the information is returned from this particular document. And I'm going to do the same for all my previous questions, my previous prompts. So there are two others. One of them, what are oil displacement prognosis according to the global EV outlook? So here you see, instead of I don't know, we've got information from the document. And the last one, what are trends in sales of electric vehicles in 2023? Looks great. This characters \n is of course sign of new line. So when you get such a response, you have to replace \n with the real new line characters for formatting purpose. And here you have it. You've seen in action an AI RAG solution using Microsoft Azure services. With this system, you now have a powerful tool for document retrieval and semantic search. Whether you're working with large text corpora, technical manuals, or customer queries, this solution can be customized and scaled to meet your needs. If you found this video helpful, please give it a thumbs up and subscribe for more content on Azure and software development. Feel free to leave any questions or suggestions in the comment below if you have questions or want to see specific topics covered in the future videos. Thanks for watching and see you next time.